Okay, so this is section 4.5, and what we're going to be doing here is finding a linear model. So a lot of it's going to be finding equation of a line, but what we want to do is think about the idea of modeling with this. So we're going to be looking at some idea in context and using our equation to model what's going on. So what we want to do, though, is make sure that we're really clear on everything ahead of time. When I say clear on what we want to do is we want to look at the pieces of our equations and linear models and understand what they mean so that we can go back and forth between writing down numbers and like writing a sentence to describe what it means. And I think that's really one of the important parts about this class that we want to sort of take away is looking at something mathematical, right? Like an equation or a number or something like that, and being able to say what it means in words. That going back and forth, I think, is something really useful. Being able to find equations and draw graphs and stuff, that's like fun in a math class. And then, when you go to your everyday life, you never graph lines again. Okay. But being able to look at numbers and describe what they mean in words, that is something that you can use, in your regular life after a math class. Okay. So when we look at our linear equation, y equals, b plus mx, or sometimes we write it as mx plus b, same idea. B is our intercept. That's the output when the input is 0. And m is that constant rate of change. Okay, so we kind of want to keep those ideas in mind when we're doing modeling to figure out a connection between the numbers and the words. All right. So what we want to do to begin with here is look at how to graph a line. So what we're going to do is say, instead of being given the equation, we're just going to be given these two pieces of information. We're going to be told a point on the line, and we're going to be told the slope of the line. Okay. So what we're going to do to graph this is start with the point that we have. So I have the point 0, 1. Remember that it always gives you the x and then the y coordinate. So my x is 0 and y is 1. So that's this point up here. And then what we need to do is figure out another point, and then we can connect them. Because it's a line, I really only need 2 points. So there's a couple of different ways that we have to go about this. One way to do this is to come up with the equation and then use that to find another point. And I think we'll do that in the next example. What we can do here is we can use the slope to tell us how to get to the next point. Because the slope is our rate of change, it's really telling us the direction of the line. Okay. So one way to think about slope is that it is rise over run, right? Or the change in y over change in x. Okay. So if I write this slope as -3 over 4, just to be clear with where the negative goes, because I don't want to go in two places, then I have a change in y of -3, that means down 3, and a change in x of 4, so over 4. So what I do is I go over 4, 1, 2, 3, 4, and go down 3, 1, 2, 3, and that gets me to another point. Oops, I went down too far. So I'm going to go down 3, 1, 2, 3, land here. Okay. And then we just connect these with a line, and we have our graph. Okay. All right. So the two pieces of information that we need are a starting point, and then we need directions to another point, and we can use our slope to do that, right? It can show us where the next point is. Okay, so we had one x value 0 with a y value of 1, And then if I go over 4, I'll be an x value of 4. And if I go down 3, I'll be... I was right the first time. I don't know why I can't count to 3 today. Okay. From my y value of 1, I go down 1, 2, 3. Okay, so that will give me this line. Can't count, I can't draw, just having a rough day. There we go. All right, close enough. Okay, so there we go, graphing a line. So that's one way to do this. I start at a point, and then I use the slope using my change in y over change in x to get to a second point. Okay. From there, we can go ahead and write the equation of the line. Okay. And the way that we can write the equation is we were given, in this case, the intercept. So I just want to be clear, this graph and this graph, even though we both have a line slope down, these are different lines. Okay, so this is a new problem. All right, so what I want to do is I want to say, all right, if I start with this equation, or with this graph, can I write down an equation of the line? Okay, and what I'm going to do is identify that here I have my intercept, right, my y-intercept. So when x is 0, I can see that y is 2. Okay, so that also tells me that b is equal to 2. Okay, and then what I can do is if I have a second point on the graph, I can use the same process that we just did with slope, except backwards. I can say, all right, well, how many over is that? Right, this is over 3, and this is down 4. Okay, so over 3 down 4 to get to another point tells me that the slope is going to be the amount over goes in the denominator, right? That's the change in x. The amount up and down is my change in y. Since it's down, I'm going to get a negative. Okay, so my slope is negative 4/3. So then I can just write down the equation because I have the b and I have the m now. So I can write y equals 2 minus 4/3 x. Okay. And we could write down what that second point is. You know, over 3 would be an x value of 3, and down 4 is a y value of negative 2. But just counting the over and the up or down was enough to get the slope, and that gives us the equation. Okay. Now let's throw some context in here. So we're going to do two things here. We're going to look at some context. Well, let's just start there. Here we're looking at salaries, right? Let's suppose that we're told that salary starts at $20,000 and increases $2,000 per year. What I want to do is look at, what is that telling me? Okay. So if I think about a starting value, and that's like when my input is 0, then that's telling me that intercept b. So when they tell us salary starts at $20,000, then I can think in terms of my model as that being my intercept. So b is 20,000. And then when they say it increases $2,000 per year, that means that my y value is going up by 2,000 every time my x value goes up by 1 or goes over 1, okay, because it's per year. So that second part is telling me that the slope, m, is 2,000. Or you could write 2,000 over 1, okay, but 2,000 over 1 is the same as 2,000. Okay. So similarly with this next one, if we're told that the value starts at 5,000, then my intercept is going to be 5,000. And then if we're told that it decreases $100 per year, my y value is going down by 100, so that's going to be a negative 100 per year. So, divided by 1. So my slope is going to be negative 100 over 1, or we could just write that as negative 100. Okay, so we want to be able to pick out from words what our symbols mean, and it's very helpful to write it down as you go, so that you're not going back to the paragraph and mixing up numbers. Okay, let's look at example 3. Price was $80 in 2005 and decreased at a constant rate of $3 per year. Okay. Let T be the number of years since 2000 and P equals price. I'm going to make a little change here. I think what we want really is for this to be the number of years since 2000. No, sorry, we'll leave it. Let T be the number of years since 2000 and P equal price. Okay. One thing that you could do that you don't have to do is look at what that means for the year. So when T is 0, the year is 2000. Okay. So when my T goes up by 1, my year goes up by 1. I'm not going to do this for every problem, but it might help just to be careful about what we're doing. So in our given information, we're told that the price was $80 in 2005. So here, when T is 5, my price P is $80. And it says that it's decreasing at a constant rate of $3 per year. So when I go to the next year, the price will go down by $3. Okay, so it'll be $77. So if we go backwards in time, if I go back a year, we have to go up by $3. Okay, then we go up by $3 again, up by $3 again, up by $3, and up by $3. Okay, so now that I've filled out my table, I'm going to use that to write an equation that relates these two together. So because my T value of 0 gives me 95, I know that that's my intercept. Okay. We would normally call this a y-intercept, but here our variables are T and P, so it's a p-intercept. I'm not going to write p-intercept, though, because I don't want to get confusing. But we're going to think of our intercept as being 95. Okay. And it says that we're decreasing at a constant rate of $3 per year, so I know that my slope, okay, I'm going down by 3 every time my input goes up by 1. Okay, so we have negative 3 over 1, or just negative 3. So if I want to write the equation, my output value, P, is going to equal 95 minus 3 times my input value, T. If you're having trouble with your variables, one of the things that you could do is you could say, I'm going to think of my inputs as X and my outputs as Y, and think of Y equals B plus MX, or you can write MX plus B. Okay. The slope is negative 3. The intercept, we said, was 95. Okay. And then you can translate back into the variables you have to get to the P equals 95 minus 3T. Right? So if the letters are confusing and you'd rather see X's and Y's, then do that. Okay. But you just want to make sure that you can translate back into the variables that we have in the problem. All right, so let's graph the equation. We want to figure out an appropriate scale, and making each tick mark 1 is not going to be a useful scale. Okay. So what we want to do is say, okay, I want to start up here somewhere. Maybe I'll make these like 5s or something like that. So this will be like 10, 20, 30, 40, 50, 60, 70, 80, 90. Okay, this would be 95 and 100. Okay, so then if I want to start at 95, that would be here. And I'm just going to make these each 1. And I'm going to I'll just pick another value that I have on my table that is a whole multiple of 5. So just use 5, 80. Okay. So there's my graph. Okay. Let's look at another example. On this one, when I filled out the table, it was pretty easy to compute all of these values mentally because it's just a change of 3. So I subtract 3 to go down, I add 3 to go up, right? That was no problem. Let's look at an example where the numbers aren't nice and see how do I deal with that. Okay. So here we're not going to be given context to worry about. We're just going to focus on bad numbers and start with that. So we're told the output y is 55.76 when the input x is 1.2. So I can write that my x is 1.2 and my y is 55.76. Okay, so this comes from this first part. Okay, now we're also told y is decreasing by 3.2 for every 1 unit increase in x. So that's going to tell me a slope, right? Slope is the change in y, so it's decreasing by 3.2 for every 1 increase in x. Okay, so my slope is negative 3.2. All right, so how would I go about creating an input-output table? How do I find this 0? Well, I'm not going up or down by a whole number, so that makes things a little bit more complicated. What I'm going to do is I'm going to take advantage of some of my formulas that I have. Okay. Now, real quickly, I want to just show you something. We talked about this before. Our slope formula is just the change in y's over change in x's. So if I have 2 points, I could subtract them to get a change in y and a change in x. Okay. If I take this formula and I just multiply both sides, so if I take m equals y2 minus y1 over x2 minus x1, and I just multiply both sides of the equation by x2 minus x1, okay, then I have x2 minus x1 times m, and on the right-hand side, this denominator will cancel, right? So I'll just have a y2 minus y1. Or if I flip sides, I get a y2 minus y1 equals m times x2 minus x1. Okay. So I get this thing called point slope formula. And since this will work for any 2 points on the line, instead of thinking of 2 fixed points, I could think of one of them as being a fixed point and one of them as being any point xy on the line. So we'll think of our x2, y2 as just being an xy point, and we get this thing called the point slope formula. You don't need to know where the point slope formula came from, but if you're curious, then that's how we get it. Okay, so here's what I can do. I know my slope is negative 3.2, and I have a point. What I can do is I can plug into this point slope formula. Say, okay, y minus, and I pick my y value, 55.76, equals my slope, negative 3.2, times x minus, and then I pick my x value, 1.2. And what I have now is an equation of the line written down. Okay, so I never figured out the intercept b, but I have my equation of a line. Now what I can do is a little bit of algebra. Okay, so now I'm going to simplify. So I'm going to take this negative 3.2 and distribute it. So y minus 55.76. If I take negative 3.2 and multiply it by x, I have negative 3.2x. if I take negative 3.2 and I multiply it by negative 1.2, I'm going to get a positive. Negative times negative is positive, and it comes out to 3.84. Okay. Now, if I decide to solve for y, if I just go one more step here and add this 55.76 to both sides, I'll have y equals negative 3.2x. If I take 3.84 and I add 55.76, I'll get 59.6. And now you notice that I have this in the form of y equals mx plus b. So this 59.6 must be the intercept b. So when I'm asked, when x is 0, what's y? Well, that's what my intercept is, so it must be 59.6. But really, I could fill out any value now. If somebody asked me when x is 5, what's y? I can just use my formula now. I could say, okay, I'm just going to plug in 5 for x. So I take negative 3.2 times 5 plus 59.6. I get 43.6. Okay, so we can find any value we want on a table once we have our equation. Okay. Oh, I think I did these next two parts, B and C, sort of over here in the margin instead of down below. Okay, so we'll just say, all right, C above. Okay, now let's go ahead and graph this using the points or the formula, right? So my y-intercept is really close to 60, so I'm going to need to change the scale on this thing a little bit. Let's just make it 10 times bigger. Let's say that this is 60. Right, and so on. Okay, so my y-intercept is 59.6, so just under 60. Okay. And when x is 5, I'll just use that point because it's nice and convenient. My y value is 43.6. So I'll go over here to 5, and I'll find 40, and then 43.6 is probably like here somewhere. And I can connect them to the line. Okay. We can check our graph using our calculator. Set y equals, and I can type in my formula. Right, so we said y is negative 3.2x. Right, negative 3.2x plus 59.6. I hit enter. I hit graph. I'm getting invalid dimension. Okay, if you get an error like that, our last unit, when we were doing statistics, sometimes we did a stat plot. Okay, what you want to do now when we're doing algebra is just make sure your stat plot is turned off, and because otherwise it might just give you errors once in a while. Okay, so now my graph should work. Now my zoom window is messed up again because maybe I did a stat plot or something. So we just hit zoom and we go down to number 6, zoom standard. Okay, and I say, well, I still don't see my graph. Well, again, this is going to go negative 10 to 10, negative 10 to 10. But my intercept is up here at like 60, so we'll just zoom out. and I can see my line. Now, you might say, hey, wait a minute, my graph doesn't look like the one on the calculator. If I want it to look the same, I want to make sure that the scales are lined up. So here, I didn't change the x scales, right? These are all 1s, but my y scales are going up by 10s. Okay. So if I want this to look just like on my calculator, just like I drew it here, you would just change the window to make it bigger. So my x values are going to go from -10 to 10. But my y values are going to go from -100 to +100. Okay, where each tick mark is 10. So my y scale here is 10. And then we can say, oh yeah, that looks like what I drew. Okay. Now let's get back to modeling, which means we need to have some sort of context and not just x and y values. So let's suppose the price of an object was $9 in 2002 and $15 in 2005. Soon price has been increasing at a constant rate, and let's let t equal the number of years since 2000. Okay. So again, it's not necessary, but it's sometimes helpful to say, okay, 2002 is going to be when t is equal to 2. Okay, and 2005 is when t is 5. So that's where I'm going to put my prices that I'm given in the problem. Okay, so in 2002, the price was 9. In 2005, the price was 15. Okay, it says to create an input-output table, and we could do that right now. It might be easier, though, to figure out the equation first. Okay. So if I want to find an equation, if I were to complete the table, and we've talked about this, right, that the 0 value gives me my intercept, and then if I go from 0 to 1, whatever that difference is going to be my slope. Okay, and I can write that down. Okay. But then I have to sort of figure out, well, how do I do this, right? I don't know what my slope is, so I don't know how to go up or down. Okay. So another way to do this is just to go back to these formulas that we just had. I can compute the slope if I have any 2 points. Okay. So what I'm going to do is I'm going to say, all right, let's first compute slope. So that's y2 minus y1 over x2 minus x1. Okay. Or in this case, t's and p's, right? Your t's are going to operate like an x, and the p's operating like an output y. All right. So I want changes in price, so I'll do 15 minus 9 over 5 minus 2. Okay. So I get 6 over 3, or 2. Okay. So I have my slope now. I can then use the point slope formula to write an equation. Okay. So y minus y1 equals m times x minus x1. All right. And I can just fill in with either point. I only need 1 point when I'm filling in the point slope formula. So I could use 2, 9, or I could use 5, 15. It doesn't matter. I like smaller numbers, so we'll use the 2, 9. So my y value is p value is 9. My slope is 2. And the x value that goes with it is 2. Okay. So then we have our 2 steps of simplifying. Distribute the 2. The left-hand side I'm leaving alone for now. So I have 2x minus 4. And now I'm going to add 9 to both sides. Okay. -4 plus 9 is a positive 5. Okay, so I get my equation. All right, if I have my equation and I want to go back and fill out the whole input-output table, because maybe I was supposed to do that, what I can do is say, all right, enter my equation. Let's clear the old one. So 2x plus 5. Okay, and now I can just go to table, hit second and hit table, and just read off the values, 5, 7, 9, and so on. Okay. Okay, so that was using formulas to do this. You didn't really have to do that, because you could have looked at it and said, okay, from 9 to 15, I had to go up by 6, and my x values were going up by 3. So that's going up by 2 each, right? If I go 11, 13, 15, I'm just counting by 2s. So I can go down counting by 2s, and you could fill that out. And when it's with whole numbers, you can do that. In our next example, we don't have whole numbers, so we're really going to have to rely on the formulas, because you're not reasonably going to be able to do that just by counting by 2s or something simple like that. Okay, so let's suppose that we're given the points, and I'm going to write these two down. We're given the point 2.8, comma 8.04. So I'll just put in an x value of 2.8 and a y value of 8.04. And we have a second point, 5.2, and a y value of 13.56. So again, what I want to do is go through that same process. I want to find the slope. Slope is change in y over change in x. Okay, so I'll take 13.56 minus 8.04 over 5.2 minus 2.8. Okay. So 13.56 minus 8.04 is 5.52. But you don't really have to even do that. You don't have to do this one step at a time. What I'm going to do is on my calculator, I'm just going to type that in. 13.56 minus 8.04. Put the numerator in parentheses, divided by, put the denominator in parentheses, 5.2 minus 2.8. And I get 2.3 as my slope. Okay, so now we've computed our slope. Slope of the line is constant, so that relates any 2 points. Okay. So what I could do is I could just repeat my slope equation and fill in what I know and solve for what's missing. What I'm going to do, though, is I'm just going to keep things simple by just repeating the same steps that I've done in earlier problems. Okay, so I could find this value by using my slope formula, but what we did before is we used that point slope equation, y minus y1 equals m times x minus x1, to just find the equation of the line, right? So that's what I'm going to do. I'm just going to fill in here. So y minus, and I'll just pick one of these, 8.04, okay, equals my slope, x minus, since I picked 8.04, I have to pick the x value that goes with it, 2.8. Okay. And then I'm going to distribute. The left side is staying the same. So I have 2.3x, and then if I take my calculator, 2.3 times negative 2.8 gives me negative 6.6, negative 6.44. Okay, and then as my last step in simplifying, I'm going to add the 8.04 to both sides. Okay, that gives me 1.6. Okay, so now I can see if x was 0, my y would just be 1.6. So that tells me that my y-intercept here is 1.6. Okay, now connecting back to something that we did in an earlier section, let's suppose I want to verify that my equation is actually correct. I was given these 2 points. What I can do is I can plug them into my equation and see if it's a true statement, right? So remember, this is an x value and a y value. So I can plug them in, right? I'm going to use y equals 2.3x plus 1.6. So I plug in the y value, plug in the x value. Okay, and I'm just going to see if things match on both sides. So if I take 2.3 times 2.8, I get 6.44. And if I take 6.44 and add 1.6, I get 8.04. Okay, so that checks out so that I know that this first point is indeed a solution to the equation I wrote down. Let's check the second one. So I write down 13.56 equals 2.3 times 5.2 plus 1.6. I'm just taking my y equals 2.3x plus 1.6 and plugging in my y value for y, my x value for x. Okay, I take 2.3 and I multiply it by 5.2, I get 11.96. And now when I add, I'll end up with 13.56 on the right. I have 13.56 on the left. So I have a true statement. So I can see that I have a solution. So my equation I wrote down is a solution for both, or sorry, the points I started with is a solution. Both of them are a solution for the equation I wrote down. Okay, so it sort of verifies that my equation is correct. All right.